Okay, guys, we have lots of examples on how to simplify monomials. Okay, if you look, these can be asked in various different ways. I'm starting with easier and I'm working all the way to pretty difficult. One rule that we need to make sure we know that I didn't include on my last video was the zero power rule. Anything raised to a zero power equals 1. Okay, so a to the 0 is simply 1. Okay. Now, example 1. 4 times a squared times b cubed times c to the 4th all to the 2nd power. Okay. So we're going to use our power to power rule here because we're raising all of this to the 2nd power. One thing you need to recognize, whenever you're having a number or a variable that doesn't have an exponent, it's always assumed that the exponent is 1. So I'm going to go ahead and write in 1s where I see that there's no exponent because there's one of them. It's raised to the 1st power. Okay? So what we're going to do is every single power here, we need to multiply by 2 because the power to power rule says that I multiply the powers together. Okay? So we're going to say 4 to the 1st power times 2, a to the 2nd power times 2, b to the 3rd power times 2, and c to the 4th power times 2. Okay? So then I'm going to simplify this. So it's going to be 4 squared, all right, a to the 4th, b to the 6th, and c to the 8th. Okay? That is my simplified monomial, and that's what I would be looking for right there. Okay? You can simply do 4 squared and multiply 4 times 4 and get 16 also. But if you have really big numbers, I'd rather you just keep them the exponents. Okay? All right. So example 2. This looks all simplified, but we have negative exponents. So when you have negative exponents, they need to be positive. All right? So I see that I have a negative 3 and a negative 2. All right? So for me to understand this, these are all being multiplied by each other. These are all multiple pieces to our monomial. It's a product. Negative 12, remember, you can't move a coefficient down to the denominator because it's negative. Only if it has a negative exponent. All right? So what I do is I can rewrite these all over 1 as a fraction to help me realize that they're all individual pieces. Okay? And negative 12, and nothing needs to happen to it. C to the 5th, nothing needs to happen to that. We have d to the negative 3rd and e to the negative 2, okay? So those need to move to the denominator because I'm saying I'm dividing by it 3 times and dividing by it 2 times. So you can rewrite this as negative 12 over 1 times c to the 5th over 1 times 1 over d to the 3rd and 1 over e to the 2nd. Notice whenever I move them down that the exponents become positive. Okay? So this also can be written more simplified all together because it's a product of things. So negative 12 times c to the 5th times 1 times 1. So our numerator is going to be negative 12 c to the 5th. Our denominator is going to be d to the 3rd, e to the 2nd power. Okay? So that was an example of negative exponents. Okay? So this is the answer I would be looking for. There's no same basis because we have a 12, we have a C, a D, and an E, and there's no negative exponent. So we're simplified. All right. Next example. Okay. We have a huge monomial. Okay. This is a monomial because everything is being multiplied together. 4a squared, b cubed, c to the 4th, 2ab. Okay, those are all being multiplied together. So you can put even multiplication signs in between all these and it's going to help you. Okay? All right, I noticed that some of my stuff doesn't have exponents. So I'm going to go in and say that's 4 to the 1st power, that's 2 to the 1st power, a to the 1st power. Okay, if you remember our commutative law, you can move anything around and it's still multiply to be the same answer, right? So this is a multiplication problem. I can move all of it around. So I'm going to regroup the things that are like together. Okay? My 2 and my 4 are both coefficients. So I'm going to regroup those together. So it's 4 to the 1st power times 2 to the 1st power. Okay, we treat coefficients just like regular numbers, okay? 4 times 2. We group our a's together, a squared, a to the first, my b's together, b cubed, b to the fifth, c to the fourth, c to the third. Okay, so all of those things are getting multiplied together, and if we remember our product rule, that if you're multiplying two things with the same bases, you simply add their exponents, okay? So since these are coefficients, you simply just multiply them like they're a normal number. 4 times 2 is 8, okay? A in a to the second power and a to the first power, you add those together. That's a to the third power, b to the 8th power, and c to the 7th power. And that is in simplified form because I don't have, all my like bases are combined. Okay, so I don't have multiple c's, multiple b's, multiple a's. Okay? Alright, so we've had an example of power to power, negative exponents, product, and now our last example over here, the easiest example, is the quotient rule. Okay? So, same thing whenever you're grouping things here. I like to group here. Okay? I also like to do, colors, boxes, highlighters, anything that can help you see that what groups together. Alrighty? Okay, so the negative 56 and 7, okay, those need to be grouped together. The m to the 5th and m to the 4th and n to the squared, and p to the 3rd and p to the 2nd. All those things can be grouped together and separated equally, okay? Alright, so what you want to do is you want to take them all separate, alright? The coefficients we treat as normal numbers. That's negative 56 divided by 7, which equals negative 8, okay? Now, the n to the 5th and m to the what power? The first power, because there's no power, so it's understood 1. We're going to say m to the 5th, and remember the quotient rule, we subtract the exponents whenever we're dividing. Is going to be n to the 5th minus 1. The end is going to be n to the 4th minus 2, and your p's are going to be p to the 3rd minus 2. Okay? So, y'all notice how I'm writing out every single step? You're not going to be able to do this in your head until you have a lot of practice, okay? So make sure you're writing out each individual step. You should at least have one step before you have your answer, okay? Unless it's just the 0 power one, which is just 1, and that's easy, okay? So, negative 8, 5 minus 1 is 4, 4 minus 2 is 2, and 3 minus 2 is 1, and you don't have to write the 1, or you can, either one. Both answers would be correct. If you were to see it on the test, though, you wouldn't have the 1. Okay, so that is simplified form. Notice my negative 8, I don't do anything with it just because it's a negative number. Sometimes we get the negative power rule mixed up with that. Okay, I'm going to stop the video and continue on with the rest of the examples.